to New Breakpoint, a series for developers by developers. My name is Michelle Sandford and I am the Developer Engagement Lead for Australia and New Zealand. We broadcast on the second Thursday of every month, and if you join us live, you can ask us questions, which my guest and I will answer for you during the show. And of course, you can also watch this episode on demand. Today, my guest is Manoj Nair, who is an Azure App Innovation Specialist here at Microsoft Australia and an expert in Kubernetes. He works with our customers to help build the Azure platform, and today he will be taking us through the Azure Kubernetes Service, which is a managed Kubernetes service on Microsoft Azure. It simplifies deploying and managing containerized applications. Manoj, you're an old hand here on New Breakpoint. You were with us in season 2, and we are so excited to have you back. Why don't you remind us a little bit about who you are and what is your role?
Thank you so much, Michelle. Excited to be back. My name is Manoj Nair. Essentially, what I work on is helping customers embrace the cloud-native services that Microsoft Azure has to offer. I typically work with the enterprise, retail, and commercial customers here in Australia. A massive fan of Kubernetes and therefore a massive fan of AKS, a product that I love to talk about. I've seen a lot of customers seeing the benefit of adopting AKS or Azure Kubernetes Service. So happy to basically be here today and talk about one of my favorite services that Microsoft Azure has to offer, which is AKS.
I've always been absolutely overwhelmed by Kubernetes. It seems to me to be a massively complex thing and not something that I would build with, because generally I just build little demos for students and developers to help them learn how to get started on Azure. So if you were trying to convince me, what is the compelling reason to use Kubernetes?
Kubernetes is that orchestrator that orchestrates the placement, the deployment, and the scalability of those applications accordingly. And it does all this heavy lifting for you by exposing your entire data center as one single compute platform. Now, this could be anywhere, Michelle. It could be probably running in your own laptop, which is running, let's say, Windows, Mac, or Linux. It could be an entire data center that you want to manage. It could be something that's running on the cloud, whether it's Azure like AKS. Or for that matter, it could be somewhere sitting on the edge. So let's say you're working for a mining industry and you basically are working inside a mine and you want to basically run some applications within that particular mine. You could basically run just a simple server, deploy Kubernetes there, and just be off with it. So in simple words, what I'm trying to say is that Kubernetes orchestrates the deployment, the management, and the scalability of your applications all by itself. There are plenty of bells and whistles. It offers you so many things, and you're rightfully correct in saying the fact that it becomes overwhelming. But the reality is that you don't need to know every damn feature of Kubernetes to deploy your applications. And that's what I'm going to show you. I'm going to show you the top 5 features you really need to be aware of in order to deploy those complex cloud-native applications on the Kubernetes platform.
And you did mention different cloud providers just then. When I was looking into it, it did seem to me that using Azure Kubernetes Service is not just running Kubernetes on top of Azure. It's actually providing a lot of stuff in order to make it less complex and easier to orchestrate. Is that right?
Absolutely. So, do you really want to be in the business of setting up Kubernetes clusters day in and day out? So you need to go and install Kubernetes, patch them, certificate management, secret management, making sure they are up to date with the releases of CNCF every year. It's not an easy task. In fact, there are certifications that are available just to manage your own Kubernetes cluster, which itself is pretty difficult, right? We at Microsoft don't want our customers to do stuff that they should not be doing. And we want to basically offload that, remove all those heavy lifting off from our customers and take advantage or provide them with a platform that comes with all these bells and whistles completely managed by Microsoft Azure. And that's what AKS or Azure Kubernetes is. It basically is a managed Kubernetes platform where the control plane is completely managed by Microsoft. You get the ability to take advantage directly into the Kubernetes objects. You can start taking advantage of Kubernetes out of the box without worrying about installation configuration. You could probably set up a Kubernetes cluster in less than 5 minutes, Michelle, by running a single command line, which is fantastic.
It sounds like there's really a lot of stuff packed into there. I do get confused sometimes about when you might use Kubernetes and when you might choose to use other containers. Could you maybe explain a little bit on the ecosystem that is Kubernetes and Azure Kubernetes Service?
Absolutely. So one of the things I always tell my customers is to not just look at AKS as a managed Kubernetes platform. AKS is part of Azure. So it brings into the spectrum the bunch of other services that handsomely complement AKS. For example, if you need to work with container registry, then we have Azure Container Registry. If you want your applications to store data persistently, they can take advantage of our storage accounts and storage services that have also take advantage of some of the security services that we offer, including Defender for DevOps and Defender for Cloud as well. So the ecosystem that Azure brings to the table is what makes AKS a compelling reason to put your applications into. Now, you asked a very important question there, Michelle. Like, there are so many container orchestrator services that Microsoft itself has to offer. For example, you might have heard about Azure Container Apps. I saw that you did some sessions around ACA in the past as well. So where would I use AKS versus ACA? The answer is pretty straightforward. ACA or Azure Container Apps is a highly opinionated platform, which means that it dictates how you want to basically go and deploy your applications. You can't pick and choose individual components. For example, let's say you wanted to use Istio instead of Service Mesh or Open Service Mesh or anything like, for example, Linkerd as your service proxy, Service Mesh. You can't do that with ACA. With AKS, yes, you can. So AKS gives you that managed platform, but it also gives you complete control to pick and choose what you want to manage and how you want to manage. So you have the complete autonomy on handling things that you want to execute within an AKS cluster. This is great for enterprises who have, Kubernetes skill sets to use and manage those clusters. Again, you don't do the heavy lifting of deploying and managing clusters, but you at least have the ability to fine tune how you want to scale your applications, how you want to do certificate management. Do you want to use native certificate management that AKS provides, or do you want to use a third-party certificate provider? Everything is completely handled for you within the AKS platform. So the most important point is, if you want full autonomy, go with AKS. You want all the bells and whistles, go with AKS. You do not have Kubernetes skills, but you want to use an orchestrator that does simple things like scaling applications for you based on demand. That's where container apps shine.
So, people generally have a lot of flexibility within our platforms as to how much visibility they have and how much control they have. But basically, if they're using AKS, they're getting all of that boring stuff done for them, and all the stuff where they might easily make mistakes because they've got hundreds of things running, all of that is abstracted away from them. But if they needed to look into it, if they wanted to control it or change it or stop it or see what it's doing, they could do that too.
Absolutely. There's a very famous saying, Michelle, no one ever got fired by choosing AKS. So if you're choosing AKS for your compute platform, be rest assured you're not going to get fired.
I feel that might have been reappropriated from another thing. I'll not say what that is now, but yes. For funsies, you could all look that up. Hey everyone, I just want to remind you that you can pop your questions into the chat at any point during this episode and we will answer them for you. We're also going to hang around for about 10 or 15 minutes at the end of the episode. So if you don't want to stop listening while you put your questions in, then wait till the end and we will wait here with you. I know you have a list of demos that you really want to show us. So yeah, maybe we can jump into that now. Can you give us an overview of what we're going to see?
Absolutely, Michelle. So what we're going to start off with is to take a look at how do you actually go and deploy your applications on AKS. And this is not native to just AKS. You can do this on any Kubernetes cluster. So what we're going to do is we're going to understand what are the capabilities that Kubernetes offers to package your applications and have them deployed on an AKS cluster. We're going to talk about deployments. We're going to see how to expose our deployments so that our consumers can connect to our applications and start, using our applications. So we're going to talk about services. We'll then take a look at some of the best practices in exposing our applications to our consumers. And this is where we'll talk about ingress controllers. Now, just deploying applications is not that fun, right? So what we want to do is to make sure applications can scale based on certain parameters. We'll talk about how to scale your applications. And then we're going to take a look at how do you basically package these applications, because in production, in enterprise, organizations, you don't just have one or two applications. You have thousands and thousands of microservices that operate in a particular application, whether it's an e-commerce website or whether it's a postal website. There are so many different components that work in together. And that's what we're going to take a look at, where we're going to see how Kubernetes and AKS makes it extremely simple to package these so-called, thousands of microservices in a much more simpler way, where you make an edit to one particular file and it does take care of updates for all the other microservices that are part of that application. All of these demonstrations and deployments are done on AKS or Azure Kubernetes Service. And to save time, as I said, I've already deployed an AKS cluster. So as you can see, I have one AKS cluster already created. It's called Let's Cube AKS 101. Forgive me for the name. I'm not very good in naming my services, but it basically displays that this is a Kubernetes cluster. It has two node pools, or what we call two nodes. So if I scroll down here, two node pools, you'll see that essentially I have a single node pool. Now you might ask me, Michelle, what a node pool is. A node pool is nothing but a bunch of machines which is where your applications get deployed to. I'm using a Windows 11 machine, and you can see that I've already installed what we call as Docker for Desktop here. Now, Docker for Desktop comes with its own version of Kubernetes. So this basically exposes your single Windows 11 machine as a Kubernetes cluster. So if you want to basically build applications locally, test them out locally, you could basically use this. It also comes with the tools that Kubernetes needs to interact with. For example, the way you interact with Kubernetes is through a command line utility called kubectl. Some people say it's kubectl, some call it kubectl. I'm in the company of calling it kubectl. So I'll be using kubectl to interact with my AKS cluster. The way you typically interact with this AKS cluster is by using context. So right here, if I run kubectl config, and if I run get context, you'll see that I have two contexts here. One is the Docker desktop, which is a local context. Now I've already connected to my AKS cluster, and that's why you'll see this asterisk here, which says that, oh, you're currently set to your Kubernetes cluster that's running on AKS, which is the AKS-based cluster. Now this is fantastic, and one of the reasons where we use context is basically to switch between different clusters. Now you might have an AKS cluster that is used for production. You might have an AKS cluster that's used for staging. You might have an AKS cluster that's used for dev. By using these contexts, I can switch between different clusters. So right now, I'm currently connected to my AKS cluster. And if I clear the screen here and run kubectl get nodes, you'll see that I have the two nodes that I showed you in the portal as well. So I am currently in a Kubernetes cluster which has two virtual machines that can run my applications, that can run my containerized applications.
Could I just ask, you set up some of this stuff in advance to save us time during the demos because we don't have a lot of time. Could you, how long did it actually take to set up?
So the way you typically install AKS clusters is, of course, you could use the Azure CLI, or you could use infrastructure as code templates like Bicep, Terraform, you can use ARM templates as well. Typically, I used the Azure CLI to create this particular cluster. It took me about 5 to 10 minutes for it to spin up the cluster. Now, you can add everything that is required to build a production grade cluster. Actually, it's a very good question that you asked now, Michelle, because in the build event that recently concluded, we launched a new service, a new version, so to speak, of deployment of AKS called the AKS Automatic. Now, what AKS Automatic does is, you don't want to be in the business of setting up an AKS cluster and then putting in all the guardrails around security, best practices and stuff like that. AKS Automatic will come in and it will come with everything that is ready for an enterprise deployment. So you can actually go and set up everything right from the scratch that is ready for an enterprise deployment of applications with all the security best practices weaved in.
One thing I have noticed about cloud is that the answer is always it only takes 5 or 10 minutes to do. I mean, some things a lot less than that. And I remember when I was working in the on-prem environments, I need to say on-premises environments because all my engineers get real mad when I say on-prem. On-premises environments, I know it used to take like months or days to get a particular PC or server or bunch of servers, I guess we called them in those days. We didn't even call them clusters back then, stood up. But now, 5 or 10 minutes is the most we would expect.
Absolutely. In fact, there's a very famous saying, right, that friends don't let friends spin up their own Kubernetes clusters. And in fact, if you are doing or self-managing Kubernetes clusters in your data centers or even in the cloud, then you're killing a puppy somewhere in the world, right? You should not be in that business at all, because what you really want is to take advantage of the capabilities that Kubernetes has to offer without worrying about the plumbing and the heavy lifting that you need to do, where you need to procure your servers, do capacity management, go and patch them, install the operating system, patch it, install Kubernetes, worry about certificates, worry about them authenticating with each other. Let's not do that. And that's a single line command in Azure that will help you spin up a production grade cluster in a matter of minutes. With Kubernetes or with AKS, what really happens is that you don't do the heavy lifting of installing and managing and patching your clusters, but it gives you them time to focus on the scalability of their applications, the way it needs to perform under load, the way it needs to perform if things go bad. What happens if a particular node fails? How do I basically react to that? That's where you spend time in. The entire process of moving your time away from deployment and management to focusing on applications is kind of underpinned with this fact that you no longer need to do DevOps. We are moving towards an age where we talk about platform engineering. And platform engineering is not just a new buzzword, or it's not the DevOps plus like most people say. It's more about gearing towards a platform where you focus on automation. So you can see that this is my AKS cluster. And as you can see, this is currently running a Kubernetes version 1.28, which is the latest version at the time of recording this particular clip. Also, I have had this created using a CLI and to connect to this via CLI. In fact, I can show you right now that this is a simple Azure CLI command to list all the Kubernetes clusters that I have in my environment. So you can see that I've connected to that AKS 101, and to basically go and connect to this AKS cluster, there's a very simple command. In fact, if you look here, right inside this particular section here, there's this connect button. So I click on this connect button, and you will see that there is this Azure CLI command to connect to AKS using the credentials. Okay. The good thing about AKS, as I mentioned earlier, Michelle, is that it's part of the Microsoft Azure ecosystem. So even if you don't want to connect using these credentials, if you already are integrating AKS with Microsoft Entra or Azure AD behind the scenes, then you can even connect to AKS clusters using your Azure AD credentials. So that's pretty awesome, because you don't need to have those credentials stored somewhere in your config files in order to authenticate to your AKS cluster. You can do just fine using this simple concept of using the Microsoft Entra IDs to connect to it. Okay. But that's a one-time process, and it needs to be done at the time of creating the cluster, or you can do it later as well. But once you connect the Entra ID service to AKS, you can't go back to the normal credentials mode. Okay. All right. So I have my AKS cluster. I've connected to my AKS cluster. How do I go and package my applications? Now, one way is you start creating your applications and containerizing your applications. Now, again, for the sake of time, I've already packaged my application up, and we will go and deploy this application using the concept of deployment. Now, you asked me a question, Michelle. There are so many things we need to learn about Kubernetes. I'll give you a small little tip on how you can use Kubernetes to teach you Kubernetes, right? So what are the different objects you typically work with? This is done, or you can get all these objects by running kubectl API resources. This will give you a dump of all Kubernetes objects that you can use in order to package your applications, build your applications, deploy your applications. For example, what we really going to focus on in this particular session is deployments. So you have deployments, you have the concept of services, you have the concept of replication controllers, replication sets. You can see that there's a bunch of services available. You can even run cron jobs or job-based workloads in Kubernetes clusters. Okay. So that's one way. Now that you know, okay, fine, I want to basically understand how deployments can be used to deploy applications. Kubernetes or kubectl offers another command called kubectl explain. I want to learn about deployments, so I'll learn kubectl explain deployments. And you'll see that, hey, it gives you a nice little, overview of what deployment is. So deployment is basically used to package an application and deploy an application. And it also tells you how to create that. And you can see that it also gives you that, the documentation links where you can learn more about deployments and, practice or copy paste commands from there. So enough of talking. Let's get into the meat. Let's go ahead and deploy our first application. So I've packaged an application called Manoj, my app. It's under my Docker Hub repository. Now, argument's sake, you can take these same images that I have available on Docker Hub. You can use them and put them into a service called Azure Container Registry. The advantage of doing that is that images don't need to be public. So if you're on an enterprise organization and you want to make sure your container images are secure and only available within that particular perimeter that you want to secure it for, that's where you use Container Registry for. Okay. But in this case, we are focusing on AKS, so I'll use the images that I have on my Docker Hub. Right. So let's go ahead and deploy our first application. We're going to create a deployment. So you use the kubectl create deployment. We'll call this deployment demo app, and I'll specify the image here. So image, in this case, is Manoj Nair / my app :v1, and the number of replicas. Now, the number of replicas is how many pods need to power your application. Now, a deployment is a high-level construct, Michelle. Behind the scenes, every deployment creates what we call as pod, and a pod is the smallest unit of deployment in Kubernetes. So if you want to package your application as containers, you typically deploy them as pods, but you don't have to manage individual pods. You manage them using deployments, because the deployments offers you a benefit of rolling back to previous versions, which a pod cannot. So it also takes care of things like, hey, you said that I want 2 replicas. I want 2 pods of my application. If I go and delete one pod, deployment will make sure that the another pod comes back again. So it is a way of telling that, hey, this is what my desired state of my application should look like. I always want that I have 2 replicas of my app running in my AKS cluster. Deployments will take care of that. Something happens to one of the pod, it crashes. Deployments will automatically spin up a new one. So the whole premise of using AKS or Kubernetes is the concept of desired state configuration. This is how my application should behave, and this is how Kubernetes will make sure that the applications behave and respond accordingly. I sometimes wish I had a Kubernetes or a desired state configuration for my kids. Unfortunately, something like this does not exist today. Okay.
Not just your kids, but for our own lives.
Our own lives, exactly.
If we could just roll back to the last point where we were perfect, and then start going forwards again from that point.
Absolutely. I wish I could have a desired state configuration saying that my kids should wake up by 7:30, be ready to school by 9 o'clock so that I can drop them off. Unfortunately, that never happens. But anyway, we digress. Coming back here, now if I hit enter, this will basically create that demo app that we have. And we can check the status by running kubectl get deploy. And notice that I used the tab key to autocomplete. This is because I used a construct in kubectl called kubectl autocompletion. I'm using PowerShell. You can do this exactly same behavior with Bash or with a Z shell as well. So it automatically completes those objects for you. As you can see, my deployment is called demo app. All the 2 pods are ready. You can check, have a look at the underlying pods by running kubectl pods, and you can see that there's this demo app pod that is created. It's up and running. Okay. You'll see one more pod called Nginx created. I did this beforehand, and I'll come to this in just a moment. Okay. So we have a deployment ready. Okay, great, Manoj. Now, how do I access this deployment? How do I connect to this application? Well, the simplest way to connect to this application is to expose this deployment as a service. A service, think of a service like a load balancer. I have 2 pods running for my deployment. A service acts as a load balancer, and then you connect to the load balancer, and it load balances your requests across these 2 pods. And the way you create a service is by using the command kubectl expose deployment. I'll call this demo app, and the type. Now, there are multiple types of services. For this particular demo, I'm going to use load balancer. It uses the Azure load balancer service, and it'll create a public IP so that I can connect to it. I'll also talk about another load balancer called cluster IP, which is what I would recommend to use, but we'll come back to that in just a moment. So I'll connect to this as a load balancer, and my application is exposed on port 80. It's a web application, so I'll connect to port 80. All right. Now, before I hit enter here, I just want to point out one thing. What you're seeing me doing right now, Michelle, is running commands imperatively. I'm using kubectl to go and create those objects like deployments and services. However, the Kubernetes, because it supports desired state configuration, it basically allows you to create these objects using YAML files as well. And you can actually generate those YAML files by running this command, try run as client, and I want to output that as YAML. So what this basically does is exposes that entire object as a YAML file. Now you will ask me, Michelle, what's the advantage of creating this YAML file? Well, the first advantage of using this as a YAML is that I can put this into a source control repository and I can version control them. I can use this YAML files to deploy my resources using CI/CD pipeline. So I can run linting tests, I can run tests, I can go and deploy them automatically using, the entire CI/CD platform, whether you use GitHub or Azure DevOps. Okay. So the good thing about kubectl is it also gives you that YAML file. So you don't have to go ahead and write this YAML files out of the box using your memory. It just spits out that YAML file for you. Now, because I used this dry run client, it has not created the service. It has just given you the YAML file. So I'm going to get rid of this and hit enter. I can now see that my demo app service has been exposed. So if I run kubectl get service, I'll use the -w switch, which stands for wait and watch. So it'll wait till the time my service gets an IP address. You can see that my demo app now has a public IP. So let me hit Control C and I'll connect to that IP. So I'll copy paste this IP here and paste it here. Hit enter. And if all things go well, then I should be able to connect to this application.
This is the part where we cross our fingers.
Cross our fingers, exactly. I hope my demo gods are with me today. There we go. Something to do with my browser. So it only works in my incognito window. But anyways, I have connected to my application, as you can see. And this is that version 1 of the application that we actually deployed to. Okay. However, there are a couple of things I don't like about this, Michelle. Number one, this application means that every time I create an application, I need to expose this. I need to create a public load balancer with a public IP. That doesn't make sense because for every application that needs to be exposed, you don't need it to be public. There might be certain microservices that might operate internally. Okay. The second thing is this is a layer 4 service. So I can take advantage of some of the capabilities that a layer 7 service could offer. For example, how about, doing things like if I have to go to michelle.com/v1, I go to version 1 of my application. If I go to michelle.com/v2, I go to version 2. So power-based routing, traffic shifting, the ability to put certificates on. That's where Kubernetes offers you a layer 7 construct called ingress controllers. Okay. And one of the things I did as a part of my Kubernetes cluster creation is I used a service called the Web Application Routing Add-on. Now, what that basically means, Michelle, is that it allows you to go and take advantage of Nginx-based ingress controllers so that you can expose your applications accordingly. Okay. To help you demonstrate this, let me actually go and show you. So I'll go to kubectl get ingress classes and notice that it shows that there is this web app routing.kubernetes.azure.com. It's an add-on that allows me to use ingress. Okay. Right now, if I do kubectl get ingress, you'll see that right now I do not have any ingress controllers. Okay. All right. So let's do this. Let's go and create 2 deployments. And I'll go ahead and say kubectl create deployment. I'll call this my app. Okay. And for this, let's use an image called Manoj Nair my app :v1. We are using the version 1 image. And I'm going to set the replicas as 2. So we created a deployment called my app. Okay. Now I'm going to expose this deployment. So I'll use kubectl expose deployment, if I can spell that correctly. Deployment my app. And this time I'm going to switch over to cluster IP. What cluster IP means is that this particular service is not going to be exposed publicly. It's going to get an IP address from the cluster, which means that you can only connect to this particular application within the cluster. Okay. Again, this application runs on port number 80. So now my service called my app has been created and exposed. If I run kubectl get service, you'll see that I have that particular my app service, and it's a cluster IP. Okay, you can see that it picks up an IP address from the cluster. It doesn't get a public external IP like we did last time. Okay, so the obvious question, Michelle, is, Manoj, how am I going to connect to this application now? Because, hey, I don't have a public IP address, so I can't use the browser. Well, there is one simple way to test our application. If you clear my screen here and I go to kubectl get pods, you'll see that I have a pod called Nginx here. What I'm going to do is this pod is running in the same cluster as that of my application deployment. All right. So what I can do is I can connect to this pod, and through that pod, I will try to connect to that particular application because all the pods are running in the same cluster. So this particular pod can connect to the other pod and try to access that particular website. The way we do that, though, is using the kubectl exec command. IT stands for interactive terminal. I want to connect to this Nginx command, Nginx pod, and I want to open a bash on Nginx. So right now, I've connected to one of the pods to its bash shell. Okay. To save some time, I've already installed a service called elinx. For those who are not aware, elinx is a text-based browser. It allows you to connect to, applications, web applications using a text-based browser. So I'll connect to http://my app. I can see that now I've connected to that version 1 of my application. So right within the cluster, I was able to connect to the other pod and connect to that application version 1.0.
Can I just ask, because you were using PowerShell before and now you're going to switch to Bash, could you continue in PowerShell here, or did you have to switch to Bash?
Absolutely. What a fantastic question. It all depends upon what container image your pod is running. This time I used an Nginx pod, which comes with Bash and Shell pre-installed. You could very well use a .NET image, which has PowerShell pre-installed, and use PowerShell. So it's up to you. As long as the particular pod or the container image you're using has the appropriate shell installed, you can actually go and even install shells accordingly. So you could basically take a Ubuntu image, install PowerShell, and then connect to PowerShell. Or in my case, I'm using Nginx that is based on Ubuntu that comes with Bash. So I just use Bash. But yes, you're right. You can use any shell of your choice. All right. So that worked, which means my application is working just fine. Okay. I'll exit out of this. And let me now create another deployment. So I'll use kubectl create deployment. But this time I'm going to call it my app v2. And the image I'm going to use is v2 as well. Okay. That's version 2 of my application. I'll hit enter. Again, I'll expose this deployment, kubectl expose deployment. Call this my app v2. And again, this will be a cluster IP exposing itself on port number 80. So if I now go to kubectl get service, I should have two services. One is my app and the other one being, my app 2. Right here. So you can see that I have these two services, my app and my app v2. Okay. Now, these are all cluster IP based services, which means they're only accessible within the cluster. To create an ingress controller, you basically create an ingress controller either using kubectl or you can use a YAML file. So let me navigate to my demos directory and you will see that I have a file called ingress.yaml. Let me explain this. Okay. So what we're trying to do, Michelle, here is to create an ingress controller that uses /v2 to point to my app v2 and uses /, which is the root of your web application, to point to my app. And it's going to say that when you go and hit the root of my application, which is the root of your website, you will be navigated to the version 1 of my application, which is exposed as a my app service. If you go and hit /v2, then you're going to go and connect to the version 2 of my application, which is exposed as service my app v2 on port number 80. It's taking advantage of that web application routing add-on that I had on my AKS cluster. And this is why it makes AKS, as I said earlier, makes all those heavy lifting very easy for you. You don't have to go and install Nginx controllers and manage them out of the box, given as a service for you to take advantage of that. Okay. Now, you might ask, Manoj, where do I learn more about this? So you could simply go and search with your favorite search engine, or you can just go to kubernetes.io. And if I come here in the site, search for ingress controller, or just search for ingress, you'll be taken to this documentation link, and that talks about how ingresses work. So you can see that this is where I actually use this particular YAML file to say that, I want to create an ingress controller. This one is using Nginx. We are using the one that's provided by AKS called the web application router. All right. Now,
so we will put all of those resources in the links of the chat so people can reference those resources during the episode, but also we do keep a GitHub repo where we store all the resources from every episode, so you'll be able to look all of that up afterwards as well.
All right, so what we've done so far is basically created that ingress.yaml file that will allow me to do this path-based routing, okay? Up until now, we've always been using kubectl create commands to create those services, or expose command to expose our services. Let's go ahead and use the kubectl create command this time, but I'm going to say that, hey, I want to use this f/f parameter to provide that ingress.yaml file. All right, so that basically has created that ingress. So if I do a kubectl get ingress now, you'll see that we have a split traffic ingress command. Again, I can use a W switch to make sure that I wait for it to get a public IP. Right now, the address part is empty. So we'll just give it a few seconds for it to pick up the public IP address. And while this is happening, because it's Windows Terminal, I can go to a different tab and we can go and connect to kubectl. Let's use kubectl describe ingress. And you can see that right now I have two path-based routing parameters here. / goes to my app, /v2 goes to my app v2. And great, we have got the public IP address. So I'm going to copy this. And let's go back to a browser and paste it here. So I've connected to version 1 of my application. Now, if I go here and go to /v2, you see that now v2 goes to the version 2 of my application. So you can see that Nginx based ingress controllers give you the ability to expose your application, but also give you the bells and whistles of using path-based routing. So you can do things like, traffic shifting, blue-green deployments, and all those goodness that typical enterprise customers need.
Actually, I noticed, Manoj, that we are flipping between application version 2 and application version 1 manually, which is pretty cool. But that reminds me of a question I did want to ask. Like rollbacks, are we able to roll back if we discover we have deployed something and it's really broken in production?
Absolutely. In fact, if rollbacks was not a feature that Kubernetes, can offer, then of course, then we really need to think what is the advantage of Kubernetes, right? And rollbacks come out of the box with deployments. So right now we have two versions of application, version 1 and version 2. So if I go back to my web application here right now, if I go to v2, you see that you're connected to version 2.0. Okay. Let's say, Michelle, that we want to deploy a new version of our application. If I go back to kubectl get deployment and just specifically focus on my app v2, you'll see that currently it's up and running with 2 pods. Great. I don't like this green color of my application. Let me switch to some other color. So let's say that we have a version 3 or version 4 of application. I can change the image that I used for this particular application by using the kubectl set image deployment command. So this allows me to edit my deployment, and I'm going to say that my app, and I'm going to change this to version 4. Let's say for argument's sake, we have a version 4 of application, and I'm changing this particular my app. In fact, let's change my app v2 to version 4. So what has now happened is we have switched that version 2 of my app v2 into a version 4 image, which means that if you go back here and do a refresh to version 2, you get this ugly looking yellow color. Okay, I was thinking that this color will look great, but then Michelle feels that, that doesn't look great at all. I need to revert back to the previous green color. Fortunately,
from an accessibility point of view.
From an accessibility perspective, absolutely. So, if I just do a kubectl rollout history for this deployment called my app v2, you'll see that we have 2 revisions. Revision 1 was the first one, which had the green color. I changed the image, and now I see that, I've changed it to a yellow color image, which is version 2 or version 4. Thankfully, kubectl allows me to do rollout undo. With this deployment, we're going to roll out the undo the version deployment that we did for my app v2. You can see it's rolled back. And if I go back and do a history, you'll see that now we have a third revision, which is basically pointing to the first image that we had. So by virtue of that, if I come back here and fingers crossed, if I do a Control R, you'll see that now we are switched back to the green version. So kubectl Kubernetes AKS makes it extremely simple for you to roll back to different versions thanks to the concept of deployment. Okay. So this is...
I just want to ask, like, that only took like a second to switch between it. If we had like clusters and clusters, if we had like 300 of them out there, would it be just as quick or would it take a few minutes?
That's the beauty of containers, right? The ability for containers is basically the fact that it just runs or virtualizes the operating system layer. It just is already active. It just needs to go and run the process that runs your application. It is instantaneous.
Oh, that's fantastic. Because I know that for our big enterprise customers, even 10 minutes is a really long time for something to be wrong. For it to be able to fix it and roll back in seconds is amazing.
Absolutely. And this all thing happens thanks to the power of containers, and then Kubernetes is a way to orchestrate that.
Oh, wonderful. So while I'm on the topic of what enterprise people care about, what about like scaling up, scaling down, all of that? Like, how quick can we do it? How do we do it? What's that all about?
Absolutely. That's again the next question. In fact, the next demo is all about scaling. So I'll give you a quick example. Now, Kubernetes or AKS gives you the ability to manually scale your applications. So you can scale the number of replicas that are powering a deployment from 0 to n number, depending upon how much you want. For example, if I just do a kubectl scale, let's go to this deploy called my app v2. And I'll set the number of replicas to 0. So what I'm doing is, hey, I'm scaling back to 0, which means I don't want any more replicas of this my app v2. And you can see that has been scaled, which means that this application, if I try to refresh now, gives me a 503 because, hey, there is no more pods to serve my application, which is not good, right? What I did right now is this manual way of doing things. In fact, I can go back here, set it back to, let's say, 10. And now it's scaled up. And if I just do a quick kubectl get pods, you will see that it already created those 10 pods for me behind the scenes. So if I come back here, do a Control R, now my application is back online. This time, notice that it's spinning up to and connecting to a different pod. So if I try to connect to this again to an in-private window, to the same URL, right, quick, you'll see that this is connecting to a pod that's ending with 5L. In the previous one, we connected to JQ or DQ. Okay, so this is the manual way of doing things. Now, doing manually is a good option. However, you want to automate that. And that's where you have the ability to use something known as the Kubernetes HPA or Horizontal Pod Autoscaler. So here itself, I'll search for HPA. And this should take me to the Horizontal Pod Autoscaling walkthrough. And here is an example where you can actually go ahead and create an application that can scale automatically based on resources. So very quickly, I'm going to copy this YAML file. This is simply a PHP application. As you can see here, it's using a PHP Apache container image, exposes itself on port number 80. The limits on this particular application is 500 millicores of CPU and 200 megabytes of memory. All right, and I'm going to call this Notepad PHP app. I'm going to paste this application here as it is. Just do a file save and close it. So if I now do a cat on this PHP app .text file, you'll see that this is it. I just need to rename this item. So I will go and say rename item PHP app to PHP app.yaml. All right, so now we have that PHP app. So I'm just going to go to a kubectl create-f PHP app. And that has now created that PHP deployment for us and also exposed that as a service. If I go back to that documentation page again, now you can autoscale your applications by saying that I want to autoscale this particular PHP application between 1 to 10 and as soon as my CPU hits 50%, I want to add one more replica. So as and when the CPU goes beyond 50%, it will keep on adding replicas to my application. So I'm going to copy this here real quick and paste it here. I've already created a PHP autoscaler here. So let me go ahead and run this HPA. You can see that we have our PHP application up and running. Currently, it's at 0% CPU utilization. And containers is awesome because with containers, you can just run a single command and run a load tester on that. So as you can see, this is the command. What we're trying to do is every second we're trying to connect to a PHP application. This will generate some load on our application. And then we're going to sleep. So we're going to do this continuously. So if I hit enter here, expect that to work. So I'm going to copy this. There you go. So now it's trying to generate that load into my application. So I'll go back to the next tab and run kubectl get HPA. And now you can see the CPU percentage increasing. I'll hit W here. So slowly and steadily, you'll see that as and when the load starts increasing on this particular application, it will start adding more replicas to your app as well. While this is happening, what you see here is the concept of Horizontal Pod Autoscaler. That means you're scaling horizontally your application by adding more replicas to your application. Oh, there we go. It started to increase the number of replicas. Now we've gone to 3 because the target has gone to 146%. So you can see that this is already working just fine. So by just creating that HPA or Horizontal Pod Autoscaler, I was able to scale between 1 to 10 pods by using the concept of HPA in an AKS cluster. That's Horizontal Pod Autoscaler. If you wish, if you don't want to go or add more pods to your application, you can increase the amount of resources on your pod by adding more resources to the existing pods. And this is done through the concept of VPA or Vertical Pod Autoscaler. I'll just show you where to find the link for VPA. So if I come back here and if I just go to your favorite search engine and if I go to VPA scaling and I search for AKS, you should be hitting a documentation link which talks about vertical pod autoscaling in AKS. And the best part I like about our documentation, Michelle, I know you are a huge advocate of Microsoft Learn. I am in your camp as well. I absolutely love Microsoft Learn.
So good these days.
Absolutely. It gives you the step-by-step process of actually even configuring a VPA. So when I created you asked me a question, right? How did I create my AKS cluster? This is how actually I created my AKS cluster with this switch called Enable VPA that allows vertical pod autoscaling on my particular cluster. And that's what and then I also use the enable routing add-on to give me that ingress controllers. But right here, you will see that it gives you the small little YAML file or an application for you to test Vertical Pod Autoscaler. So as usual, we'll provide the link to this particular documentation.
So it's going up more and more. And as it does that, as the load increases, I like that it was pretty slow at the start. So you're not having to spend more than you need to. But it's really only bringing it up as your application demands it. Will it downscale it as well by itself, or will it stay up there at the most expensive thing?
What we do in cloud is we scale up quickly because we want to meet the demand of our customers. So we want to make sure our application remains online. However, we try to scale back slowly because you don't know whether that drop in demand is temperamental or not. So you might probably have all of a sudden, from 100 customers, you go to 80 customers. But you don't want to completely scale back your applications because you might have that temporary glitch where, it's probably a shift time and customers are moving to a different version, blah, blah, blah. In such scenarios, we try to scale back slowly. So with HPA, it tries to scale back slowly and it will come down to 0. So you will save on the resources, you will save on the pods. It will free up those pods for your application behind the scenes. But yes, the scale back will happen slower as compared to the scale up process.
So it's aligned to ensuring that the customers that they are serving do not feel any pain from this. They automatically get access to the application when they need it, and they don't get kicked out of it as demand goes down. They still have access to it while they need it, and it will just gently scale back. That's
Absolutely. Absolutely.
That's
All
cool.
right. Cool. Now, there's one thing I want to talk about, Michelle, and that is if I look at all these files here, for example, if I look at this ingress.yaml file, okay, this is just for one application, one service, so to speak, right? Or maybe a couple of services because we're using path-based routing here. Now, imagine, Michelle, you work for an enterprise and you have to appoint 300 applications running. And you need to keep in mind, oh, okay, version 2 is actually version 2 of my application that uses version 2 of my container image. And if I update my container image to version 3, I need to make changes to all these YAML files that are spread across my Kubernetes clusters, right? For example, in this case, I need to make sure that I go back and change this service to version 3. I need to go back to the actual deployment file and change that version to version 3. Oh my God, this can be cumbersome. Like, how would you keep a track of, okay, I have an application that uses deployments, that uses services, that uses jobs. How do I keep a track of changes where I make one modification to one specific component, let's say a deployment, and I need to make sure that the same changes replicate across services and jobs and stuff like that, right? This is where Kubernetes gives you one more higher level construct called Helm charts. Okay, and this is by far one of my favorite features because what it basically does is for enterprise customers who run this pursuit of applications within their AKS cluster, it gives you a high level construct to manage those dependencies, so to speak. And the best part is just like Docker images, these Helm charts are available for you to directly download. For example, Michelle, you said, okay, let's say for argument's sake, you want to go and deploy a WordPress cluster or WordPress application in Kubernetes. You don't have to go and manually create those deployments because a WordPress Helm chart is already available for you to deploy. So you can use Helm to basically go and deploy already prepackaged applications for you. And all these are available in the different Helm repositories that are available. Now, to save time, I already have Helm installed on my machine. On a Windows, you can use Winget. On Mac, you can use Brew, or in Linux, you can use a native command line CLIs to install Helm. So you do have Helm installed. So I've used the latest version of Helm. And I'll show you a quick example of how Helm works. So let's say that, I go and say Helm create, and I'll call this argument's sake demo. I'll call this Michelle app, right? So what it has done is it has created or scaffolded a bunch of files for me to work with. So if I just navigate to this Michelle app now, and if I do a quick ls, you'll see that it has created what we call as a chart. So if you do a cat on this chart.yaml, this is nothing but a description of your application. So if somebody's trying to understand what does Michelle app do, you can put all those deploy information here. Michelle app is a WordPress website that does this, blah, blah, blah. Its application version is, it's an application. There are two types of charts you can create. One is application and other is a library. Think of library as a dependency. So what if, you need to create, or you're creating a Redis based application. So you want to allow this Redis to be used multiple times within other applications or embed them, so to speak. You can take advantage of the library here. This one here is an application. It's version 1.0. The version of the application itself is 16.0. So you can obviously fine tune this as well. However, this is not where the fun is. The fun is inside this file called values.yaml. So if you look at values.yaml, this is nothing but a YAML file that gives you all the parameters that you can customize. So if your application is exposed on port number 80, I can come back and say, yes, use this values.yaml to replace what is currently been there in the actual ingress.yaml file. So think of this, Michelle, like your deployment via biceps. When you use bicep to deploy infrastructure as code, you can change the parameters it needs. For example, a storage account name, whether it should be public or private, at runtime by providing a parameters.yaml file. Similarly, in case of Kubernetes, you can override the values at runtime by using this values.yaml file. So in this case, it's a cluster IP. It's exposing itself on port number 80. In fact, let me actually go to Notepad and search this values.yaml file right here. And I will change this cluster IP to load balancer, just for argument's sake. Save this. Now get rid of this. So I've changed this for cluster IP to load balancer, but you can see that all these value files are nothing but parameters that you can change on runtime. And where do I define the actual artifacts? Well, if I go back here and do an ls, you'll see that there is a templates directory. So if I go to templates directory, this is where you see all those goodnesses, the deployment.yaml file, the hpa.yaml file, the ingress.yaml file. So let's have a look at that ingress.yaml file, and you will see that instead of using the actual names of application, it uses a concept known as dot values. So it's picking up those values from the dot values, the YAML file that we created. So in this case, it says that, oh, if you want to replace this service port, get it from the service port, which is picked up from this values or YAML file. Similarly, if I just do a cat on the service.yaml, you'll see that similarly here, it picks up values of the type from the YAML file that is there, the values.yaml file. So go have a look at YAML file, which is values.yaml, and pick up the service and its type from there. So you can change just the values.yaml, and it propagates those changes across your different components like services, ingresses, deployments, and stuff like that. So one change in one file makes you or gives you control to control the, or gives you the ability to control the overall application versions of your applications. Okay. And now the $1 million question is, that's great, Manoj, but how do I do the deployments of this? And that's actually done by using Helm. I'm clearing the screen here. So I'll just do Helm install. I'll call this Michelle app. And I'll just go and say this is the Michelle app. And if everything goes well, you can see that now I've deployed that Michelle app application. It takes care of using the load balancer approach to create that IP. So if I do a kubectl get service, we are waiting for Michelle app. It's already picked up that IP address here. That's the service. And if I come back here, it should connect to the application, which is the Nginx version of our application in just a moment. But the whole point of using Helm is to create that one single package that encompasses everything you need to know to deploy your applications across.
So it's automation, but it's fully customizable automation, and yeah, super easy, and they can put as much into it as they want or as little into it as they want because the defaults are all good as well.
Absolutely. And you could use things like Helm --help to get the list of all the commands that you want to basically work with Helm. So for example, if you want to create repositories, you can delete, you can check the status. In this case, you can see that if I do a Helm list now, it will list that Michelle app that I have. You can also do things like Helm history with Michelle app to see the revision. Now, just like deployments, Michelle, you can even roll back using Helm. Imagine the power here. You're basically having this component complex application which has these ingresses, the deployments, and blah, blah, blah. And using one command, you can revert back the entire application itself. Not just the deployment, but the entire application itself. And you can do this using the Helm rollout or rollback command as well.
I think that you could talk all day on all of these different exciting things in Kubernetes. And I blame myself because I did tell you that I found Kubernetes really difficult to understand and hard to get excited about. So I can see that you're trying to swing me over to it. And all the amazing features. But I do think that we probably have to stop now. Is this a good spot, or is there anything else that you want to close with on that?
There's one thing I want to definitely talk about, Michelle, and that is what you saw me doing today is all about creating all these commands via a command line utility like terminal, or in your case, if you're using Mac, you'll use Windows, or you'll use a bash shell or whatever it is. But in production, you want to actually go and take advantage of a CI/CD suite. If you're interested and if you're available in Sydney, there is a KCD event, Kubernetes Day event, that's happening in Sydney on the September 5th and September 6th. I, along with some of my colleagues, are going to talk about how do you use GitHub Actions. Now, if you haven't, unless you're living under a rock, you might probably have heard about GitHub Actions. I can see, Michelle, you're a big fan of GitHub. But GitHub Actions is awesome. It is an automation platform that allows you to not only interact with your code repositories and react to different events like a commit or a push or something like that, but it gives you much more control on the ability to do CI/CD. And with GitHub Actions, you can automate the rollout of these applications onto AKS. And that's what is going to be covered in our workshop that we're going to run on the 5th of September, where we're going to use the power. Imagine, Michelle, GitHub Actions along with AKS. I know you can see the hair standing on my hand right now. It's just going to be super awesome. It's going to be a match made in heaven for our AKS customers. So if you're there in Sydney, I would love to welcome you for that particular event. It's going to be fun-filled. It's going to be complete hands-on. There's no PowerPoints at all. So you'll just get to see how to roll out applications using GitHub Actions onto your AKS clusters.
I cannot wait for that. I am definitely coming to that workshop, and I will be there for Kubernetes Day as well. So yes, we are encouraging all of our customers to sign up for that, and we will see you there. Manoj, thank you so much. I really appreciate your time and expertise, and your passion for this subject has been very inspiring. I'm sure a lot of us will now feel much more equipped to give Kubernetes a try, and definitely the workshop with you and Kubernetes Day in Sydney will be another great step for me to learn and continue on that journey. So we've been answering a lot of questions online, and I'm sure there are a few more. We will stay around to answer them for another 10 or 15 minutes, and you can find all of our resources from this episode, as well as additional AKS training modules on Microsoft Learn. So thank you all for tuning in, and we look forward to seeing you again on New Breakpoint next month.
We hope you enjoyed this digital event. We have specialists on standby to answer your questions for a short while. To ask a question, type it into the chat window now and we'll get to it as quickly as we can. You'll also find a resources widget in the bottom middle of your screen. We've put additional links in there to learn more about what we've covered today. Lastly, tell us how you found this experience through the survey widget. If you're not staying for the Q&A, thank you for attending, and we hope to see you again soon.